Welcome to part 3 of the video on the Fundamental Theorem of Calculus. In this third part, we're going to solve some definite integrals using the Fundamental Theorem of Calculus. So now that we have this theorem, we can calculate definite integrals like this one. Here we have the definite integral from 0 to 1 of x squared dx. The Fundamental Theorem of Calculus says that this definite integral equals f of 1 minus f of 0. And what is f? F is any primitive of x squared. That is the function that we're integrating. And how do we find primitives of functions? We already know how to do that. You just need to find the indefinite integral of the function. In this case, the indefinite integral of x squared is x cubed over 3 plus c. So we take f of x equals x cubed over 3 plus c. So we have that using the Fundamental Theorem of Calculus, this definite integral equals f of 1, that is f evaluated at the upper limit, there is 1 in this case, and we get 1 cubed over 3 plus c minus f of 0, there is f evaluated at the lower limit, that in this case is 0, and we get 0 cubed over 3 plus c, and we get that the two c's cancel out, and this is 0, so we have that this equals 1/3, and that's the answer for this integral. So let's try to understand what this means. Here we have the graph of the function x squared, and what we calculated is this integral, the integral from 0 to 1. Here it should be 1, not 2, from 0 to 1 of x squared dx, and we prove that this equals 1/3. And this integral represents this area that is in red here. It is the area under the curve from 0 to 1. And this is 1/3, and this is pretty amazing because if you think about it, this shape that we have here is pretty strange. It is kind of strange. You don't learn to calculate areas of these shapes in basic geometry, but using calculus you can calculate the area of these shapes and even more complex shapes. So this is pretty amazing. Let's see another example. Here we have the definite integral from 0 to pi of sine of x dx. So the first step is to calculate the indefinite integral of this function, and we know how to do that. The integral of sine of x is minus cosine of x plus c. And in the previous example we saw that when we took the primitive as the function plus the constant cancels out when you use the Fundamental Theorem of Calculus because you have a difference. So you don't really need to take the constant, you only need to take the function here. So we take f of x equals minus cosine of x. Using the theorem, we have that this definite integral equals f of pi minus f of 0. This term here is f of pi, there is f evaluated at the upper limit, and we get minus cosine of pi minus the primitive evaluated at the lower limit, and in this case is 0, so we get minus cosine of 0. So here we have that minus cosine of pi equals 1, and minus cosine of 0 is minus 1. So we get 1 minus 1, that equals 2. And that's the answer. So let's try to understand again, graphing this function. This is the function sine of x in the interval 0 to pi. This point here is a point pi on the x-axis, and what we just calculated is this integral that represents this area here, the area from 0 to pi under the curve, and we proved that this equals 2. And this is pretty amazing. Just to compare, here I draw this square of side square root of 2 that also has area 2. So we prove that the area under the cube equals the area of this square here, and that's pretty amazing. So that's all for now. Thank you for watching and see you next time.